Hello, Hiba.
Good evening, sir.
Good evening. So, in the last classes, we are discussing basically the general motion. General motion means when the body is moving linearly also and it is rotating at the same time. Okay, it is rotating at the same time. So, first we have seen the displacement in the rolling motion, or you can say in general motion. So basically, general motion we have divided to study the general motion. Uh, we have divided the general motion in translational motion and the rotational motion separately. Okay, to analyze the motion. Okay. After that, first I discussed what will be the displacement in case of the general plane motion. And after the displacement, we have seen what will be the velocity, means how to calculate the velocity for different points in general plane motion. We discussed very easily, and we have done some numericals also. You can see here some of the numericals we have done. After that, I discussed the acceleration in general motion. So I told you there will be the three acceleration, and you have to add these acceleration vectorically. Okay. After the acceleration, we have done some question on the acceleration. And today we'll discuss the linear momentum in rolling motion. Linear momentum. So linear momentum is basically the product of mass and velocity. If a body is moving, for example, if there is a body, if this is a body or mass m, and this mass m is moving with velocity v, then the momentum of this mass will be the product of mass and velocity. Okay, in the scalar form you can write p is equal to mv. P is equal to mv. But here the body, this is a body, and this body have center of mass and velocity of center of mass is v, and this is rotating at the same time, means this is performing the general plane motion, means moving linearly and at the same time rotating with an angular velocity of omega. So in this case, how we will find the acceleration, not acceleration, linear momentum. So basically, if this body have the mass m, if this body have the mass m, and v is the velocity of center of mass, then I'm telling the result. The net momentum of the body performing the rolling motion. Okay, performing the rolling motion. Rolling means moving linearly and rotating at the same time. You will get the result mass into velocity of center of mass, mv. Total mass of the body multiplied by velocity of center of mass. So now we will derive this result. Okay, we will derive this result. Okay, so for deriving this result, we know that this body is made up of masses. Okay, different masses this body is made up of. Suppose one mass is here, m1, another mass is here, m2, another mass is here, m3, another mass is here, m4, and so on. This body is made up of n number of masses, n number of masses. And one mass is here also, and take this as m4. One mass is here, you can take, this will be m5. So this body is made up of n number of masses. Okay, so to calculate the linear momentum of this body, uh, what we should do, if we can find somehow the momentum of each and every mass, and after that we will add that momentum vectorically, so we will get the total momentum of the body. Okay, if we want to find the net momentum, P means momentum, linear momentum is represented by P. So P net, if I want to find of this body, then it will be m1 into velocity of mass m1, m1 v1 plus m2 v2 plus m3 v3 and so on. Now this mass m1 will have different v1 different velocity, m2 will have different velocity, m3 m4. You can see here, if you can take this point P. So for this point P, first velocity will be, I'm just checking the velocity of mass m4. Okay, so this will have the velocity in this direction. Just a minute. So for this mass m4, there will be velocity of center of mass v. Okay, and due to the rotation, there is velocity in the opposite direction, that is will be r into omega. That will be r into omega. So basically the velocity of point P, net velocity of point P will be v minus r omega. Now for this mass, if the mass is here, for this mass, there will be one velocity in this direction. That will be the velocity of center of mass, that will be v. And there will be another velocity due to the rotation, that will be perpendicular to this mass. That will be r omega. That will be r into omega. So for this mass m5, the velocity will be the vector summation of v and r omega. So from here we can analyze different masses will have different velocity. Different masses will have different velocities. Okay. So now what we will do? If I am writing for mass m1, for mass m1, okay, this is mass m1, and this mass m1 is having the velocity, suppose v1. This mass m1 have the velocity of v1. So if I want to find the velocity of mass m1, velocity of mass m1 with respect to the center of mass. Okay, for this mass m1, I am just finding the velocity of this mass with respect to the center of mass, not with respect to the ground. Earlier, all the velocities we have seen with respect to ground. If nothing is mentioned, then we will assume the velocity with respect to the ground. So for this mass m1, the velocity of mass m1 with respect to the center of mass means if someone is watching this mass m1 from the center of mass, that is the meaning of velocity of mass m1 with respect to the center of mass. So it will be velocity of mass m1 with respect to the center of mass. So it can be written as velocity of mass 1 with respect to ground minus velocity of center of mass with respect to ground. We can write this. From here we can find velocity of mass 1 with respect to the ground is equal to velocity of mass 1 with respect to center of mass, or you can write in this way: velocity of center of mass with respect to ground plus velocity of mass 1 with respect to center of mass. So What is this? This is the relation, okay, between the velocities. So velocity of mass 1 with respect to the ground, if you want to find this mass 1 with respect to the ground, if you want to find, then that will be equal to velocity of center of mass, okay, velocity of center of mass with respect to the ground, plus velocity of mass 1 with respect to center of mass. So this point you should remember. For example, if you want to find the velocity of mass 2 with respect to ground, velocity of mass 2 with respect to ground, so how you will find? First you will write velocity of center of mass with respect to ground, velocity of center of mass with respect to ground, plus velocity of mass 2 with respect to center of mass. For example, if you want to find velocity of mass 3 with respect to ground, so it will be velocity of center of mass with respect to ground plus velocity of mass 3 with respect to center of mass. Okay. And velocity of center of mass is basically v here. Here in this case it is v. Velocity of center of mass with respect to ground is v. So velocity of center of mass with respect to ground is equal to v. Okay, now we can find this. If it is written that velocity of mass 1 with respect to ground, so it can be written like v1 also. If nothing is given, means we are assuming the velocities with respect to the ground. Okay, so v velocity of mass 1 with respect to the ground can be written like this also. Okay, if it is written that velocity of mass 2 with respect to ground, it can be written as v2 also. Okay, after that this relation we will use m1 v1 plus m2 v2 plus m3 v3. So from this we can write m1 v1 we can write. So what is v2g? What is v1g? V1g is v1. So v1 we can write. Okay, basically this v1, this relation we can write in this way also. If nothing is, if, v1g can be written as v1 because it is with respect to ground, and it can be written as velocity of center of mass. Okay, velocity of center of mass plus velocity of mass 1 with respect to center of mass, and this is in vector form. So v1 we can write vc plus v1c. So velocity of center of mass plus velocity of mass 1 with respect to center of mass plus m2. Instead of v2 we can write vc plus v2c. For m3 we can for v3 we can write vc plus v3c and so on. And what is vc? Vc is the velocity of center of mass. Velocity of center of mass. Okay. So now from here we can multiply m1 into vc and m2 into vc, m3 into vc. So we will get m1 vc, m2 vc. So basically what we will get, we can take vc as common. So we will get this m1 into vc plus, from this bracket we will get m2 into vc, from another bracket From this bracket, we will get m3 into Vc and so on, plus another term we will get m1 into V1c, m2 into V2c, m3 into V3c. We will get m1 V1c plus m2 V2c plus m3 V3c and so on. Okay. Okay, now from here Vc we can take common. Vc we can take common and it will be m1 plus m2 plus m3, m1 plus m2 plus m3 plus and so on. Okay, and here you will have this plus you will have this m1 into V1c plus m2 into V2c plus m3 into V3c and so on. Now one point I want to tell you, if suppose two masses are given m1 and this mass have the velocity v1 and here is another mass m2 having the velocity v2, and if here is a mass m3 and this mass have the velocity v3, so there will be the center of mass of these three masses. Okay, for these you can take two masses only, okay, to understand better. This is mass m1, this is mass m2, so there is some center of mass of this m1 and m2 system. This is a system of mass, and for this system of mass there will be a center of mass. If you want to find the velocity of center of mass, velocity of center of mass of this system, it will be given by m1 into v1 plus m2 into v2 divided by m1 plus m2. This will be the velocity of center of mass, and obviously this velocity of center of mass is with respect to the ground. With respect to the ground, if nothing is given, then the velocity we will take with respect to the ground. Okay, now you can see this part. This part, it is m1 into v1c, m2 into v2c and m3 into v3c. Okay, so it is looking like it is m1 v1 plus m2 v2 m3 v3. If I divide it with total mass and multiply it with total mass, there will be no effect. So now see this term, it will be m1 v1 m2 v2 plus m3 v3, and what is m? Capital M is basically m1 plus m2 plus m3 plus m4, sum of the masses. Okay, it will be m1 plus m2 plus m3. Okay, you can write in this way also. Now what is this? What is this whole term? This term, this term will be the velocity of center of mass. This term, this term will be the velocity of center of mass. Now here nothing is given, so here this velocity is velocity of center of mass with respect to ground. With respect to ground. But here already this velocity is with respect to the center of mass. So from here you will get velocity of center of mass with respect to center of mass you will get. Okay, it will be velocity of center of mass with respect to center of mass. Okay, and velocity of something with respect to something will be zero always. Okay, if I am saying this mass is m1, okay, if this mass is m1 is moving with velocity v1, if I am saying velocity of mass m1 with respect to mass m1, so it will always be zero. So velocity of center of mass with respect to center of mass will be zero. Means this term will be zero. This term will be zero. So net momentum will be this only. Net momentum will be this only. So net momentum will be what? M1 plus M2 plus M3 will be the total mass and multiplied by velocity of center of mass. So from this relation you will get the net momentum, that is equal to total mass m multiplied by velocity of center of mass.
So,
Yeah.
how did you get the last part?
Hmm?
The last one? The
Uh,
P net
th-
equals.
this part, this one.
No, the one after.
Hmm? Actually, your voice is not clear. Just tell me once again.
So, can you hear me now?
Hmm,
Can you
this
hear me?
part. Actually, your voice is breaking.
Can you hear me?
Now I think it's okay. Now tell me, what are you saying?
Um, so P net equals MVC.
Oh, this you are saying, this one.
Yes, sir.
Actually, VC is velocity of center of mass. Okay, I'm writing here. Basically, this is VC, velocity of center of mass. Okay, VC is the velocity of center of mass. Okay. So what we have done nothing, but we have used the concept of the relative velocity here, and we have applied here. Then we have this result. Basically, if you don't understand this derivation, you can remember only this formula. If a body is rotating at the same time and moving linearly with the same time, and having the velocity of center of mass as vc, and total mass is m m is the total mass of the body, then the net momentum of the body will be mass into velocity of center of mass. Okay, net momentum will be mass into velocity of center of mass. Okay, you can write down now.
So,
Yeah.
so the very last step,
Okay, this one.
like from no, from
This one.
the yeah, from there to P net equals MVC. Yeah,
This one.
yeah, like the last step.
So actually na, this one is the net. Actually, you are saying from where I got this.
Yeah, from capital M. Yeah.
Huh. Actually, see this equation. Okay, basically this total momentum is equal to Vc multiplied by m1 plus m2 plus m3. Basically, m1 plus m2 plus m3 is this mass m. Okay, body is made up of masses m1 plus m2 plus m3 and so on. This is equal to the total mass of the body, that is equal to m. So this term will become 0. This term will become 0. So we have only this term, and this term is capital M. So that is why we will get capital M into VC. So that is why I have written M into VC. Now understood?
Yes. Sir.
So okay, actually now you have to practice this derivation one or two times. Then you will understand it more clearly. Okay, write down. This is the most difficult chapter in physics. If you are not understanding the derivation part, then you can only learn this formula. Most difficult chapter in 11th physics, I will say, because here is the linear motion as well as the rotational motion at the same time we are using.
Done, sir.
Okay.
Done, sir.
Okay.
Done, sir.
Okay. Suppose this is a disk and this disk is rolling. Rolling means this have the this is moving linearly, at the same time this is rotating with an angular velocity of omega. So angular velocity is given. This is the question basically. Angular velocity of this rotating disk is given 2 radian per second. 2 radian per second is given. And velocity of center of mass is given, that is equal to 2 meter per second. This is also given. And okay, this is given. And this body, this disk has the mass of 20 kg. And this disk is rolling on the surface. Now we have to find the momentum of this disk. Find the momentum of the disk. Find the momentum of disk. So how we will find the momentum? We have the formula of the momentum. Net momentum of the disk is equal to mass into velocity, mass into just a minute. Okay, so it will be the total mass of the body multiplied by the velocity of center of mass. Total mass of the body multiplied by the velocity of center of mass. So you can find the momentum. Total mass of the body is 20 kg and velocity of center of mass is 2 meter per second. So 2 meter per second. So you will have 40, okay, kg meter per second square. Kg meter per second square. So this will be the momentum. Okay, you should know this formula, mass into velocity of center of mass. So in rolling motion, the momentum is this. After that, we have the kinetic energy in rolling motion. So I will write only formula this time. Kinetic energy in rolling motion. So if this is the body and this body have the velocity of center of mass is Vc. Vc is the velocity of center of mass. And this body is rotating with an angular velocity of omega. So if you want to find the kinetic energy of this body performing the rolling motion, then kinetic energy will be kinetic energy is equal to half total mass of the body into velocity of center of mass square plus half into moment of inertia about the center of mass into omega square. Now kinetic energy of body is basically this kinetic energy, and this kinetic energy is due to the linear motion. This is due to the velocity of center of mass half m into vc square, and this half I omega square is the rotational kinetic energy we have seen. Okay, so total kinetic energy will be half m into vc square plus half I omega square, and I is the moment of inertia about the center of mass. So remember, in rolling motion, total kinetic energy is kinetic energy due to the linear motion plus kinetic energy due to the rotation. So due to the linear motion, the kinetic energy is half m into vc square, and vc is the velocity of center of mass. You can write here. Vc is the speed of center of mass, or velocity you can say. Speed of center of mass. What is I? I is the moment of inertia about center of mass. M is the total mass of the body. M is the mass of the body. Omega is the angular speed. Omega is the angular speed. Okay, first write down this question, this and this, then we will discuss the questions on the kinetic energy. You will see how the questions will come in exams.
Done, sir.
Okay. So remember, means if you in a rolling motion, momentum is mass into velocity of center of mass, m into vc. Simple. And for the kinetic energy, half m into vc square. What is vc? Velocity of center of mass plus half I omega square. Okay, total kinetic energy. Okay, write down this.
Done, sir.
Okay. Okay, there is a sphere. Okay, this is a sphere. In the question it is given. There is a sphere. What is this? This is sphere. This is the center of mass of the sphere. R is the radius of the sphere. Okay. Omega, and this sphere have the velocity of center of mass Vc, and this is rotating with an angular velocity of omega, having the radius r, and this is this performing the rolling motion. And this is a solid sphere. Solid sphere. This sphere have the mass of 2 kg given in the question, and this sphere have the radius 2 meter. Angular velocity with which the sphere is rotating is 3 radian per second, and velocity of center of mass of the sphere is 5 meter per second. We have to find the kinetic energy. Find kinetic energy of motion. Kinetic energy we have to find. Now this sphere is performing a rolling motion. Now for the rolling motion, the kinetic energy is given by half m into vc square. For the rolling motion, the kinetic energy is equal to half into mass of the body into velocity of center of mass square plus half into moment of inertia about the center of mass into omega square. Now half mass of the sphere is 2 kg. So we will put here 2 kg multiplied by velocity of center of mass square means 5 square. It will be 5 square plus half multiplied by moment of inertia. Okay, so moment of inertia of a sphere. What was the moment of inertia of the sphere? 2 by 5 mr square. You can see here. We have done moment of inertia here, I think. So solid sphere, na? So if you have a solid sphere, the moment of inertia about the center of mass having the mass m radius r 2 by 5 mr square. 2 by 5 mr square. Okay. So for the sphere, the moment of inertia is given by 2 by 5 mr square. So it will be here you can write 2 by 5 mr square. What is m? M is 2 kg. What is r square? R square means 2 square. Okay. It will be 2 square. Now we can solve it. So this 2 and 2 will be cancel out. This 2 and 2 will be cancel out. So we will have 5 5s are 25 plus here this 2 and 2 will be cancel out, and it will be 2 to the 4 to the 8 by 5, and here we have omega square also. Okay, here we have omega square also. Okay, this I have not written. Omega square means 3 square. Omega square means 3 square. 3 square. So it will become 72. Okay, because this will be 2 to the 4 to the 8 and 3 3 is a 9, and 8 9 is a 72. 72 by 5. It will be 72 by 5. So the answer will be, it will be 25 plus it will be 5 1s are 5, and it will be 2, and it will be 5 4s are, and 5 4s are. So it will become 25 14.4 4 5 4 9 2 or 1 3. The answer will be 39.4 joule. Can check the calculation also. Okay, so you have to remember the moment of inertia of a sphere about the center of mass, that is equal to 2 by 5 mr square. So that is why I have written here the moment of inertia. So at least these moment of inertia you should learn, because these will be used in the formulas. Okay, so in this way you can find the kinetic energy in case of the rolling motion, half m into vc square plus half I omega square. Okay, okay, write down.
Done, sir.
Okay. Now there is one more question we have.
So,
Yeah,
should the value of kinetic energy be in joules or kilojoules?
yeah, it will be in joule. No, this is not kilojoule. Okay, remember the unit of kinetic energy, any type of energy, is joule. Kilojoule is something different. If it is written as 1 kilojoule, so it means 10 to the power 3 joule. Kilo means 10 to the power 3. For example, 1 kilogram is equal to 10 to the power 3 gram. Okay, fine.
Yes, sir.
There is one ring. There is one ring. And this ring is rolling down. Okay, this ring is rolling down, and this ring have the mass m, radius r, and this ring is initially at rest. What is the meaning of initially at rest? Here, this ring will be at rest initially, at rest. And one relation is given. Angular velocity of the ring is equal to linear velocity of the ring is divided by r. This is given. Means this ring will rotate with an angular velocity of omega, and this ring will move with velocity of v, like this, in downward direction. And this surface is smooth surface. This surface is a smooth surface. They are asking, find the angular speed of the ring. Find the angular speed of ring when it reaches the bottom most point. When it reaches the bottommost point. Okay, write down this question. We will discuss this question in the next class. And one more thing is given, the height, this height is given as h. Means from here to here, the height is small h. We will discuss this question in the next class. Write down this question. Or you can try this question by yourself also. Done?
Thanks, sir.
Okay. Now, Hiba, which chapter is going on in your school?
So we just started oscillations.
Okay, just started the oscillation. Okay, so actually now what I will do, this chapter will be finished mostly in 2 lectures, because this rotational motion is a little bit difficult also to understand. That is why the my speed is a little bit slow in this chapter. So we will start after this chapter the oscillations. Okay, so in the remaining chapter we will uh, discuss